Hello, just got done fighting with Leonard. My name's AJ Kumar, Dr. AJ Kumar, PhD. He, him. Let's see. Um, we're not reading that. Not reading that. We're not reading that either. Not reading that. We're reading this. This is Euclid's Elements, Book 1, Proposition 2. And I'm going to open up GeoGebra. This one's actually confusing, so I will probably publish the GeoGebra thing. Okay. Turn off the grid, turn off axes. So blank piece of paper. So the way this starts is we have a line actually, we start with a point, which is A, and we have a line segment somewhere. So I'm just going to put it over here. Okay, and what we want to do is we want to make a line segment emanating from A that has the same length as this one. So how do we do that? Okay, procedure's a bit weird, but first thing we do is we join A to B. Now, we use the procedure from the last one to construct an equilateral triangle. So how do we do that? Remember, make two circles, and then you have this new point up here. Great, now we have an equilateral triangle. Now, let me try the ray. Let me see what that does. Okay. First thing I'm going to do, actually, so I'm going to, I'm going to This is red and bait style. I want to emphasize that this is sort of the main thing. And this will be pink. No. Okay. So, first thing we do, make this equilateral triangle. I'm going to make these gray just to emphasize they're not very important. So now we've got an equilateral triangle. How does this help us? Okay. What I'm going to do is I'm going to make an equilateral triangle. How do I do this? Okay, let's read this. Right. Produce straight lines AE and where's E? AE, okay, and BF. So what we're gonna do? We don't really. Let's try the ray tool maybe. Let's try that. See if that works. Okay. I don't like this. I don't like rays very much. These are sort of very unnatural mathematical objects, but whatever. We'll deal with them. Sort of lines or line segments. Pick one. Rays are just. It's weird. I guess we're supposed to make a segment that's like longer than this. Anyway, okay, you know what? I'm just gonna pick lines. I'm gonna go with lines because the ray thing is really bothering me. Okay, it's wrong. Okay, so we've got these rays here. Now what are we doing? Circle CGH, center B, and radius BC. Okay, so we make a circle here. Do that. We have a ruler, we have a compass. Okay. A circle. Center G. Okay. Now there's this new point down here called G. Okay. And to be consistent, I'm going to pick it. God damn it, GeoGebra. For fuck's sake. Half of this, by the way, is going to be me cursing at GeoGebra. This is called G. Okay. Just to be consistent. Okay. We have G down here. Okay. Now we make a circle DG. Okay. Here we are. Okay. Now, what I want you to note is that this length from B to G. So I wonder. Here's what I'm going to do. I'm going to make segments. Here's what I'll do. Okay. And what I want to show you, take this segment. I'm going to take these lines and make these. These are secondary to the construction. So, okay. Let's make these 9. How about that? Okay. I want you to notice that, and let me take this one and make it, let's make it purple. Take this, make it purple. So now what I have is purple plus red equals purple plus red. Or in other words, red equals red. Right, because purple plus red, these are both radiuses of the, let's call this the purple circle, okay? And we'll make D nice and purple. Okay, and this will be our red circle. Does that work? Yeah, I think this diagram maybe illustrates the idea a little bit better about how to create a copy, how to copy a line segment. Translating a line segment. Okay. And then what we can do, it doesn't have to be in just this direction because, of course, what we can do is take a circle here. And now we can make, you know, for instance, this line segment. And so how do we want to do this? I'm going to call this how to copy a radius. Okay, and let me make this red. How about let's make these green. Yeah, let's do green. Is that better? I don't know. No. I think red is good. Red. Let's go with red. Anyway, that's the construction in this theorem. Let's read the notes here. I'm going to turn the grid back on, and then make these nice and aligned. There. Now it's really pretty. I think this figure is totally symmetrical. Maybe I'll... Yeah. Let's say how to copy a circle. Something like that. The point... maybe... Oh, that's actually an interesting idea, which is that this is... So there's... Here, I was showing you this compass tool, which was this idea that I can make a compass and pick it up and put it somewhere else, right? here I can make the same compass again. I can pick it up and put it over here. And this is the formal procedure for how to duplicate a compass. Okay, that's what I'm going to call this, how to duplicate a compass. All right, let's so let's see, join the straight, yeah, postulate, what is that, making it, yeah, I can join I, which is constructing an equilateral triangle, right, which was, okay, right. Right, so right, this is one of the common notions. Equals subtract, yeah, right. If equals are subtracted from equals, then the remainder are equal, right? Okay. Right, that was how I have, well, dg, so purple plus red is equal to purple plus red. So dg is equal to d, is that E it looks like? Yeah. dg is equal to de. And if I subtract the purple from both of these, then, anyway, then equals subtracted from equals, then they're equal. Right. So this is how to pick up, how to move a compass. Right. This is very clever. There's no motion in the geometry of Euclid. There's something like motion used in a different. Okay, that's interesting. We'll have to see. Where's postulate 3? To describe a circle with any center and radius. Right. So the question is, can I pick up a compass and put it down somewhere else? Which is what I can do with this compass tool. So I can make a compass, pick it up, put it somewhere else. And so this is that, can I do that? And this is a construction that allows us to do that. Let's see. It's a collapsing compass, right? It's right. So this is interesting. So I could probably do this just in the painting program, because GeoGebra I have a real compass tool. In the painting program, all I have is a straight edge and the ability. Let me try doing this in the painting program. So I'm going to save this. This is Euclid elements 003.ggb. Okay, I'm going to try this in the painting program. Okay, so what I have is a point. Got too much shit on my desk. Point and a segment. Okay. I want to make a circle. What? Circle. circle. That's all I want. Okay. Okay, so I'm going to construct the... Let me construct the equilateral triangle. There's a fair amount of eyeballing here involved here. So it's Euclid's geometry is kind of what you might call a synthetic geometry. I think that's the phrase. What synthetic means fake. And that it doesn't really make a lot of sense, although it clearly works, you know, in a sense. Okay. And let me... Okay. Now, let me pick a new color. Oh, it's Christmas themed, isn't it? So we want to do something like this. So this is how to pick up a compass and put it down somewhere else. Okay. Now what do we do? Ah, right. God, motherfucking damn it. God, this annoys the shit out of me. Why can't these programs just do exactly what I want? Exactly when I want it to do them. Don't do something I don't want you to do. Do what I want. It's that simple. There we go. Christ's sake. Okay. Stop fucking with me. Okay, here we go. Now we've copied our compass, for Christ's sake. Okay, so it works in the painting program as well. Erase this. That's cool. So this might be useful if you're like an artist. Anyway, so we're going to see that there's actually quite a lot of deep math in Euclid's Elements, but anyway. This is cool. I'm going to save this. There we go. All right, let's see. Right. Okay, so this is used in the next... Okay. Anyway, that's all I have to say. Thank you for watching.